the opening session here, how serious is the climate crisis and how could it affect us, a briefing for trade unionists. This section is going to be given by Professor Kevin Anderson, who's Deputy Director of the Tyndall Centre for Climate Change Research. Kevin will speak for quite a reasonably long period of time in order, and that's necessary obviously for us to do what we had hoped to do, which is give that sort of thorough understanding about what is happening. There will be some time at the end for questions, so if you do have a specific question, keep that in mind and we'll send the mic out to take those at the end. But meanwhile, Kevin, over to you.
Thank you very much. Right, I've got about 45 minutes-ish, there or thereabouts. This won't be a very uplifting talk, and it won't have many pictures. In fact, that's it. There's no polar bears or emperor penguins or droughts or anything like that. There's words and there's a few graphs and there's some numbers. But I'll try and make it at least moderately interesting. What I'm going to try and do is it'll be a whistle-stop tour really from the science of climate change, but with a principal focus on issues of emissions. So actually it's the emissions that really matter. The science is all pretty much just in my day just O-level physics, but the science is relatively straightforward, but it's then understanding what's happening in terms of emissions. I'm going to try to bring that towards the end, so some suggestions about how we can get off the sort of fossil fuel train that we're on at the moment and try to bring emissions down and try to lead into some pointers for this particular event today in terms of jobs and the economy. I've called the talk here Real Clothes for the Emperor, and I'm not sure if you'll be able to see it, so I'll have to read quite a lot of it out, I think, because I think at the back it's probably just a little postage stamp to you. I've called it Real Clothes for the Emperor, which hopefully you all know that story. In my view, the mitigation emperor, despite having the Committee on Climate Change, despite a lot of good work that has been done in the UK and elsewhere, but as far as I'm concerned, they are completely naked. And they've been running past this for the last 20 years since the Earth Summit in 1992, for those of you with grey hair or no hair that can remember that particular event. The emperor has had no clothes since 1992, but we keep pretending that they're fully dressed, and we continue to do that with dressed in emissions trading scheme or carbon tax or some other spurious measure that we always talk about. So that's the sort of base, the framing of the talk, and we're going to face the challenges of climate change. The global context. I'm going to start off here with a quote from the International Energy Agency. These are not a left-wing think tank. They have traditionally been the sort of, in some respects, they're the organ of the established energy industry, which is principally fossil fuel based. So they have in some ways been the mouthpiece of the fossil fuel industry. So it's interesting that they're saying these sort of things, and they're saying them regularly. They're not saying them once or twice. They're saying this sort of thing, they're putting in their documents repeatedly. Now, admittedly, you can look at other documents they produce that seem to counter this, but this is their overriding message here. This is from their chief economist, Fatih Birol, but you'll find the same sorts of comments from their CEO as well. When I look at the CO2 trend data, it is perfectly in line with a temperature increase of 6 degrees Celsius, and you talk about during the century by about 2100. And this would have devastating consequences for the planet. Now, whether it's 6 or whether it's 5 or whether it's 7 or 4, I mean, what he's saying is that we are moving towards a world that we cannot comprehend at all. It's worth bearing in mind that 5 to 6 degrees C temperature rise or temperature difference is what you see between the Ice Age and now. So these are temperature changes of that sort of order of magnitude that we're heading towards. The new head of the World Bank, again, not also known for being a radical organisation, Jim Yong Kim, said that at 4 degrees C he would anticipate seeing food and water fights everywhere. And you can see, you think, oh, that might be exaggerating, but look what happened in Darfur when the pasture lands changed a little bit there. People didn't reach for the debating table to negotiate their limited resources. They reached for the Kalashnikov and fought and killed each other. So this is not an unreasonable sort of comment to make, that as the resources become more and more constrained, and as climate change feeds into other stresses anyway, that we are likely to see those sorts of outcomes. So it's incumbent on us, I think, to try to avoid these. So what of the UK? What have we signed up to? Now, hopefully some of you will be familiar with this. The Copenhagen Accord 2009-2010, the Cancun Agreement, and all the other great international negotiations that we continue to sign up to. Indeed, the Camp David Declaration last year, where David Cameron signed up with the G8, and also the UK's Low Carbon Transition Plan. They all say something along these lines. This quote is actually taken from the Accord. The UK is committed to make its fair contribution to hold the increase in global temperature below 2 degrees Celsius. Notice that, below. It doesn't say a 50-50 chance of, or thereabouts. It says below 2 degrees Celsius, and to take action to meet this objective. Now, these are two quite radical statements. Firstly, consistent with science. policymakers are saying they want to be consistent with science, let's hold them to it. And on the basis of equity. And that, again, both of those things we repeatedly sign up to. So let's hold our paymasters to what they state. Every year they sign up to this. They'll be doing the same thing in Warsaw this year. So what we have there, we have the emission trends heading towards 4, 5, 6 degrees C. But actually the rhetoric is much more around 2 degrees C. And I just want to put that in some sort of perspective now. Looking at this is, I think, might be the only graph. There might be one more graph. Those of you who can't see it and see the numbers, it's the shape that matters mostly. Right, the side, this axis here, the y-axis, the up-axis, that's in billion tonnes of carbon dioxide, gigatons of carbon dioxide, so it's lots of CO2 basically. And the axis along the bottom is a date from 1980 out to 2050. So for the lives of quite a lot of us, I think, probably. And what I want to point out here is what's been happening to emissions. In 1980, the emissions were about 20 billion tonnes, 20 gigatons of carbon dioxide that we're pumping into the atmosphere from fossil fuel combustion primarily. And in 1988, which was being recognised already as a problem, the United Nations set up the Intergovernmental Panel on Climate Change that was initially chaired by John Houghton. So the first chair of that organisation was a British chair. So that organisation obviously is still going now and produces scientific reports every few years. In 1992, there was the Rio Earth Summit. Notice the emissions. The Rio Earth Summit was about 20 billion tonnes. That's at the time of the Rio Earth Summit. But there or thereabouts. And hopefully a lot of you remember that, and people were quite upbeat and optimistic about issues of sustainability, Agenda 21, and climate change and biodiversity, and all these other things that came out of that. Really quite positive meeting. But by 2000, here you've got the Royal Commission report on environmental pollution, talking about climate change. And they came up initially then, it was a slight misreading of it, that the government started to adopt this target of a 60% reduction in emissions in the UK by 2050. David King, 2004, climate change is the most dangerous threat we face, more so than international terrorism. Copenhagen in 2009-10, and then the Rio Plus 20. Now people hopefully most of you remember or have heard about Rio Plus 20, it was on last year. Most people thought of it as Rio Plus 20 years. I see it as Rio Plus 20 billion tonnes of carbon dioxide. Because actually, whilst we've been flying around the world to all sorts of exciting jamborees on climate change, the emissions have doubled. So that is our success so far, to recognise a problem and to make it twice as bad as it was when we first recognised it. That's what we've managed to achieve in 20 years. And that's probably the good news. We're now going through, it's unfair to say it's a global economic downturn. It's probably an economic downturn in the West, significantly, in the OECD countries, but even some stagnation in countries like India and so forth, and a slightly slowing down of the economy in other parts of the world. But at the same time, emissions have been going up at phenomenally fast rates, despite the fact we're seeing a slight dampening in the world economy. Globally in 2010, they went up by 6%. Now, I think that's a higher increase in 1 year than occurred during the Industrial Revolution. And remember, it occurred from a very large number. So we're already at a very high level, and the growth rate is enormous, and it is not going down. It's at 3–4%, and that sort of rate, that's the rate of increase in CO2 emissions from a very large number, year on, year out, year in, year on. So what's going to happen to this in the future? We know quite a lot about the next few years. We're unlikely to see some radical change in the next 2 or 3 years, and we start to plot what this might look like. But it's worth bearing in mind that what we're doing now is locking in the future to certain ways of doing things. So the energy system, if you think about the design lines for those things, if you build a power station, a nuclear power station or a wind turbine or a gas-fired power station, whatever you want to build, they're going to be there for 25 to 50 years. So when we build something today, it is going to be there providing electricity for the next 3, 4, 5 decades. When you build a building, or put in a sewage network, or put in a transmission network, they're going to be there probably for 50, 100, maybe even longer. I don't know what's to happen to this building when it's got rid of. Well, I'm not sure when it was built, but I mean, it was built some time ago. I guess it was the 60s looking at it in here. And whether it's going to knock down or keep going, I don't know. The building I'm in was built in the 60s as well. Most of the buildings that we're going to live in 2050 are already built, and many of them were built in 1930. So we are locking ourselves into the infrastructure when we build something new. So we have to bear that in mind every time we do it. And if you think of aviation and ships, both areas I've worked on, they traditionally last about 30 years once you've actually constructed them and they're flying. The 747 was designed in 1964, first sold in 1969, and people still fly it today. Okay, it's tweaked a little bit, but it's still basically a Whittle jet engine from 1936, I think it was. So they're still the same plane. So the A380 Airbus, if it follows the same path, would be gracing our skies, if we call it that, in 2070 and 2080. So they're the sorts of timeframes that we're locking in. That's why it's really important to make the changes today, because if we don't make it today, we can't make it tomorrow, because tomorrow's too late. So let's imagine that we can do as much as we say we're going to do at the moment. We're not doing these things. Remember, this is a global picture. And let's see where that would take us. The emission curve will look something like this. This is not a do-nothing scenario. This is do quite a lot scenario. The emissions are going in that sort of direction at the moment. And if you then say, well, actually, climate change, and I'll come back to this later, is all about the area under the curve. In other words, the emissions. The emissions are the bit under the curve. So if you look at the area under that curve and say, well, how much is there? For those of you who haven't been interested in the numbers, it's about 3,000 billion tonnes between 2000 and 2050. And you can relate the amount of emissions you pump into the atmosphere to the temperature. It's not perfect, like a lot of science, there's a lot of uncertainties, and in climate science there's more uncertainties than many other areas because it's very complex. But you broadly get a feel from this that suggests that we are heading towards a 4 to 6 degrees C temperature rise during this century. And again, if you come from, I live in the Peak District just below Kinder, where the mass trespass started, 4 to 6 degrees sounds quite pleasant to me. So we have to think, well, how does that play out actually regionally? How come that, what doesn't sound like too bad a number, actually, what are the impacts of that? Because they are pretty devastating. I'll come back against that later. But that's what we're signed up to. I don't know if you can see that, the difference between the two. That's the rhetoric, the 2 degrees C, and that's what we're doing. Look at the gap between them. The gap is enormous. So the question that I think needs to be asked is how do you transition from the rhetoric to what we say we want to try and do? And let's not pretend 2 degrees C, I'm not going to go into that today, but let's not pretend that 2 degrees C rise is particularly good. Many people around the planet will die at 2 degrees C. They'll be poor, and they'll be a long way from here, by and large. A few might be in this country as well, and some people may benefit in this country from 2 degrees C temporarily, and certainly parts of northern parts of Russia they will do. But 2 degrees C will kill many people around the planet. So we're not talking already, even if we hold to that, we're not talking about an equitable division, because the people it will kill, by and large, are people who have hardly emitted anything. This is from the Committee on Climate Change. I'm quite critical of government and the committee on and off during this talk. But I should say that I have a lot of time for the fact that the UK put in place the 2008 Climate Change Act and actually also set up the Committee on Climate Change. We have a lot of time for the people there. They're doing a very good job. They claim to be independent, or they're said to be independent. They're not really. They still have to play to a political message. And over a pint, they sort of admit this. This is from their report in 2009 and 2011. To keep global average temperature rise close to 2 degrees centigrade, the UK must cut emissions by at least 80%. And I'll come back to that later as to why that doesn't make much sense. And the other bit, of course, if you want to get anything published in this world, you have to then add this section. The good news is that reductions of that size are possible without sacrificing the benefits of economic growth and rising prosperity. Because that, of course, is we can all be swimming to work as long as we've got economic growth and rising prosperity. And I will come back to that later because I think that's not viable. Well, I'll come back in a couple of slides. There's an alternative take on that. This is based on the same science, so I'll come back to that again as we go through. If we think it's appropriate, when we think about it, climate change is a global problem. We've got a global budget of carbon dioxide to use. And if we think it therefore appropriate for the poorer parts of the world to have actually some emission space so they can improve their welfare, they can increase their energy consumption in the poorer parts of the world. And my guess is with an audience like this, you're all going to take that on board. You probably all take it on board, honestly. All audiences say, yes, we agree with that, but many of them don't really, they talk quietly. But, so we all think that poor people should have a larger part of the budget than us, those of us that already caused the problem. And if that's the case, you then have to ask the question, well, what's left for us? And our conclusion, from looking at the same science, is that it's difficult to envisage anything other than a planned economic recession. Now, I know that may be possibly in this audience, or in many an audiences to do with the unions as well as it is with the politicians. That's not a popular term. Now, you can try and make it, put it a contraction, put it whatever you want it to be. Find some other nice words for it, but it's the same. We all know it's the same thing. So, planned economic recession being compatible with stabilisation at or below 650 parts per million. For those that are interested in that, it's about 4 degrees C. So even for a 4 degrees C future, there isn't enough emission space for us to keep on growing our economy, to leave a little bit of emission space for the poorer parts of the world. And I'll come back to how we're playing with those numbers deliberately in our policies in the UK at the moment, where we're actually basically saying that the poor people should have no more emissions. Now, it is worth bearing in mind that that's only necessary once you put low carbon energy supply in place. If you had a low carbon system, then it wouldn't be a problem. But we're not going to put one in place quite quickly. It will take probably a few decades, even if we tried hard, and we're not trying hard yet. No one's trying hard yet. So until you can do that, until you get the low carbon supply in place, then you have to cut back on how much energy you consume. I'll come back to that with this curve here. Remember those curves I showed you? That's the one we've got supposed to aim for. Now, when you think about that, you've got to come off the curve now. You've got to start bringing the emissions down now. We should have started to bring them down 5, 10, 20 years ago. But actually, that's the initial part of that is too early for supply. If you like nuclear power stations, how are you going to get by? I mean, they are low carbon, even if whatever other concerns people may or may not have about them. They are low carbon. But how many are going to get built by 2020? 1, 2? How many are going to get built by 2030? 5, 6? How many wind turbines are going to get out? A few. Yeah. How much carbon capture and storage? Well, we haven't done one big power station around the world on that yet. Nothing at the gigawatt scale anyway. So at the moment, there is nothing that we can do on the supply that will bring us off that curve fast enough. So the only option to start off with is reduce demand. So the only thing that we know that can get us off the curve fast enough is to reduce our demand for energy. And that basically means, because we have to reduce it so rapidly, and because we think it's fair that we reduce ours much quicker than the poorer people around the planet or even in our own country, then that actually means that we probably have to cut back on what we consume. Because in the short term, we won't be able to consume as much as we are and come off that curve. Now that's not to say the supply side, the technologies aren't important. They are really important, and in fact, they're the sort of things that I've traditionally worked on. I come from an engineering background, and I've played with lots of big bits of shiny kit, and they will do a lot of good things. Engineers can do a lot in this sort of time frame. But you're talking about 2025, 2030 before you start to get significant penetration of low carbon supply technologies. So why is it that there's such these I think are quite radically different conclusions. You've got the Committee on Climate Change, a respected group of people who really know their stuff, saying, hey, 80% reduction, and we can do that with a few tweaks here and there, and rising prosperity and economy and so forth. And you've got us saying, hang on, that doesn't look viable at all. We're going to have to cut back on what we consume in the short term. How does that arise? Well, this might sound a bit nerdy, this bit, but it's actually really quite important, because like a lot of things, there's sort of devils in the detail. I'm going to go back to the 2 degrees C target, and I can write up any statement here at all. This is the Copenhagen Accord, and it says, hold below 2 degrees Celsius. The UK's low carbon transition plan must rise no more than 2 degrees centigrade. Now, all of the statements say something like this. They're never saying a 50-50 chance of. They're always saying you must not exceed. And if you say it's must not, you assume there's a reasonable chance you're going to try not to. Not that there's a very high chance you're going to exceed it. So if you think about that, and then you translate that language, which is sort of a language of adjectives, if you like, into numbers, because people like me have to have numbers to give us some idea of what the emissions curves look like, with reduction curves. I'm using here the Intergovernmental Panel on Climate Change. They have a taxonomy to translate adjectives for the policymakers and the rest of us into numbers. Quite handy to use this one, we've signed up to it. But by and large, they're saying that if you use language like hold below, must rise no more than, that is at best a 10% chance of exceeding it. No more than that. But the UK government's policies are all premised, and this is their number, not mine, they're all premised on a 63% chance of exceeding the target. So that's already an enormous fudge. Now, does that matter? Well, it does, because the carbon budget, the amount of carbon you can emit for a 63% chance of exceeding 2 degrees C, compared to the 10% chance, is twice as much. So you tell me what you want your mitigation policies to be, and I can fudge the numbers to give you an answer for 2 degrees C. And that's basically what's happened here. So we've got a 63% chance. Now, there's 2 things about this, and I think I'll come back to a bit later. The 63% chance does not take account of equity. So that is not, when we bring that down to the UK, we're taking a much larger slice of that cake than we should really be taking. So not only are we fudging the probabilities, but we're then fudging the fairness issue. And when you put those 2 together, we end up with these sort of policies that people like the Committee on Climate Change and the government can come up with at the moment. And indeed, many NGOs have fallen into this trap as well. So when you think about this, what I'm saying here is the UK government's carbon budget under the Climate Change Act, the 2008 Climate Change Act, the carbon budgets that we have in the UK at the moment, which are almost legislatively or in statute, they are twice the size of the carbon budgets that accompany our international commitments that we sign up to every year. So there's a big difference. We've got 2 budgets. We've got one that's international, that we keep saying, hey, this is what we're going to be doing, and another one that's national, this is what we've actually legally made binding for the UK. And these are completely different and change the whole policy environment. The implications of this are profound. The UK's current budgets are neither consistent with science or on the basis of equity. Now that's a sort of a radical departure from the conventional view, but all using conventional numbers. It's also worth bearing in mind, you'll have presumably heard of some of these things. 80% reduction by 2050 or a 60% reduction by 2050. This has nothing to do with climate change. We should never use this language, and nor should any scientists use it, even though they repeatedly use this language as shorthand. But shorthand has become accepted science. I would refer to this as it's large reductions by not in my term of office. And we all like it. We laugh about it, and we think that's true. We think about politicians, but we like it as well. That allows us to carry on living our lives, going on our holidays, not having to change fundamentally what it is that we do. So everyone, businesses like this, politicians like, we all like this. So it means we can really pass the problem on to technology in the future and our children. But the CO2 from keeping these lights on in here, and keep this projector running, will be in the atmosphere for 100, 200 years. Probably 20% of it will be there for up to 10,000 years. So we are changing the climate now for the next hundreds, possibly thousands of years by holding this event. So that it tells us that the build-up of CO2 that matters, not some spurious target for 2050. But that shift from a long-term target, which is meaningless, to actually towards cumulative emissions, i.e. the build-up of CO2 day in, day out. When these lights are on tomorrow, if they're on tomorrow, they will add to the CO2 from today. And that build-up means you're concerned with the cumulative budget, the area under the curve. And that changes the whole chronology, changes the timeline of climate change. From one where we focus on long-term reductions, wind turbines in 2030, or nuclear power, or whatever, carbon capture storage, wherever it might be, biofuels. It takes us from that to saying, actually, when we go home tonight, we've got to not get the tube, we've got to walk, turn the fridge off when we get there, and live a completely, almost in our country, a zero carbon life, and we should have started doing it quite a lot of years ago. So it changes the whole chronology from about the future to about now. And that of course, is unpopular with all of us. We don't like that, and hence, by and large, the whole population is sort of taken up with this cognitive dissonance, this way of deliberately scamming the whole system, or this science, if you like, of climate change. Now, in addition to these set of changes, there are some other ways that we are tweaking the data, if you like, to give us answers we would like. And I think these are ones that we need to start to push harder on. Firstly, almost all the emission scenarios that are out there from the Committee on Climate Change, or from the people that advise the Committee on Climate Change, but also right around the globe, they always underplay short-term emission growth. We know what the emission growth will be in the next few years. It'll be 2, 3, 4, possibly as high as 5%, but probably somewhere between 2 and 4%. Yet they almost never embed that emission growth, even in the short term. So that already means that they're playing with just the next few years. They all, almost without exception, will assume that emissions will peak very early. By 2016 is the Stern report. Have you heard of the Stern report? Yeah. The Stern report, do you know when the emissions were assumed to peak in that globally? 2015, globally. So did anyone think that in 2006, when Stern was writing this, he thought emissions were going to peak in 2015? In 9 years.
Couldn't find out. You seriously couldn't find out.
Yeah. So we can't think that those sort of assumptions that is viable, and then to do the economic analysis in the back of that, I think is actually quite dangerous, even though I like this economic analysis. But it's worth bearing in mind at the moment, the UK policies, which were advised in the Committee on Climate Change, are premised on an assumption that the global emissions will peak in 2016. Does anyone here think that is reasonable, that global emissions will peak in the next 4 years, 3 years?
I do.
You think, right, good, that's one. I hope the rest of us are wrong. That's all I can say. I hope the rest of us are wrong on this. They also assume, in that, you have to assume that the emissions from China and India will broadly peak in 2017. Does anyone think that's viable? Remember that China is about 1/3 of the global emissions of CO2 at the moment. I'm not blaming the Chinese. They made my Mac laptop, and they probably made they made these clothes, they were European, but anyway, they made a lot of the things that we use all the time. I'm not blaming the Chinese, but they're 1/3 of emissions of CO2 at the moment, and they're looking to increase their emissions significantly over the next 5, 10, 20 years. So that's what our policy is based on.
Peak then. I think that as well.
You think what they'll peak?
In 2018.
Well, again, I hope you're right on that one. The reduction rate, in other words, the coming off the curve, how fast we can possibly achieve, is being dictated in all the analyses out there by a group that I call astrologists, that other people call economists. They're much cheaper to employ astrologists, and they're usually more accurate. And I'm being a bit unfair there, because there's only a particular group of economists, and I think that they're applying their approach to a problem that's not suitable for them. I might come back to that later. And we're talking about very large changes, and they're applying economic theories that are based on very small changes. So We're being told by economists that if you want economic growth, you can only come down at about 2 to 4% per annum reduction rate. And that dictates all of the science, absolutely all of the science on this. And the assumptions in all the scenarios out there is that geoengineering, in other words, ability to suck the CO2 out of the air, it just exists, that we can actually do that. We've not done it so far significantly. The assumption is that it will always be there in all of the scenarios. So I think that's a completely unreasonable set of criteria on which to base your analysis. Not saying you shouldn't do one or two analyses like that, but there should be other ones that say actually China may not peak in 2017. And there should be other things out there that counter that. Consequently, we have very different views on 2 degrees C. This is taking the government and the Committee on Climate Change approach, and this is the paper that Alice Bowes and myself had published in the Royal Society a few years ago. And increasingly people are sort of saying this is not too, they accepted this as a sort of as a factual account of where the numbers are taking us. The chance of exceeding 2 degrees C, the government's got a 63% chance of exceeding 2 degrees C. I don't think that's reasonable. I don't think it's reasonable to expect the poor people in the world, living in the lower parts, particularly in the southern hemisphere, to have to put up with the sea level rise and the devastation that will cause to them. There are 30 million people living within 1 metre sea level rise of the coastal strip of Bangladesh. 30 million people, half the population of the UK. And of course that area is also vulnerable to storms and so forth. We said that we thought there should be, at worst, a 37% chance of exceeding 2 degrees C. We don't think you can get any better than that now. We've left it too late. But in 2013, we've pumped out 400 billion tonnes of carbon dioxide since 2000. We're already doing it. We say global emissions could peak in 2020. In fact, our new analysis, which we've not quite completed, says 2025 now. We think that's too early. The Committee on Climate Change in 2016. We say poorer nations should be allowed a longer period to reach their peak in emissions. That seems fair to us. The Committee on Climate Change have a very early date for that. We think deforestation is not the responsibility of only the countries that deforest. When I came down yesterday by train, there were virtually no forests in the UK, because we have deforested. We have to have the benefit of lots of land and using the forests. I don't think it's fair to say the countries that are deforesting, all of the emissions should relate to them. And somewhere between probably 12 and 20% of global CO2 comes from deforestation. We look at the mitigation rate, or you can't see it from the back, but the difference in terms of the rate of reduction of emissions is that if you use the government's analysis, it's got to be 3% per annum. Ticks the box for economists. If you use our analysis, it's 10% per annum. 10% in emission reduction every single year to give you an outside chance of 2 degrees C. So that is not looking particularly hopeful. So where does that leave us? I think a lot of people would suggest that 2 degrees C looks too difficult. And we hear this all the time. Well, we can't do 2 degrees C. And that's actually a very common debate now amongst a lot of scientists and policymakers. 2 degrees C is too challenging. We can't do it. And you can see why they're saying it. So what about a 4 degrees C future? That sounds more viable. Firstly, you have a larger carbon budget, and therefore if you have a larger carbon budget, you haven't got to mitigate emissions quite as fast, so we've got a bit more time to get these technologies in place. But 4 degrees C means mean global surface temperature. You have to think about it. Most of the planet is made up of oceans, of water, and water has a very high thermal mass. So, but if you're going to have a 4 degrees C global average, that means your land temperature probably is an average of somewhere 5 or 6 degrees C. So you're seeing a higher temperature on land. Now, if you follow some of the work, and this should come with a caveat, there's a lot of uncertainty around this, as there is with all this sort of area of climate science. But this is from the Met Office, the Hadley Centre based in the Met Office. They do a lot of the modelling for the UK and for the UK government on climate change. And they're trying to say, well, give some sort of handle on how this might play out. What would that mean for the hottest days of the year? So think of the 2003 heat wave, when 20,000 to 30,000 people died across Europe. A lot of other people died in other parts of the world, but we don't really care too much about that generally. This would mean that during the heat wave like that, in China you would see a 6 to 8 degrees C temperature rise. So imagine they had 2 months of really hot weather, and most of their buildings now they're putting up have no thermal mass in them. So that means that they're very hard to keep cool. You have to put air conditioning units on them. It's also worth bearing in mind that as the temperature goes up, you evaporate the soil, the moisture out of some of the soil. Most of the cables in cities around here for electricity are underneath the ground. Actually, it's the moisture in the soil that is really important for keeping the cables cool. So as the cables can't cool, they can't transmit as much electricity. So at the same time we're putting our air conditioning units on and our fridges and freezers are working extra hard because of the heat wave, the cables can't send the power down the lines. So you start to see a whole host of things that start to occur that cause problems. And London's, 3 days worth of food in London. If your fridges and freezers go down, it's probably about half an hour. So you start to see other sets of issues that start to come on board this. In the UK, in Central Europe, but think of our system. It's a Victorian system. The sewers were put down there. A lot of the cables have been put down in the last many, many decades. The water network often is quite old. A lot of the buildings we stay in, the building opposite, a lot of the buildings are old buildings. This infrastructure was not designed for large populations. Now, we've got large populations in structures that were designed for a long time ago, not for this new climate. 8 to 10 degrees on the heat wave in 2003. So the tarmac will start melting. The tubes won't be running. You won't be able to run your fridges and freezers as much as you'd like to, if at all. So there are lots of other issues start to come on 10 to 12 degrees C in New York. So these are huge changes from a 4 degree C temperature rise. Now, I don't really care too much about Europe and New York, because I think we've caused the problem knowingly. So I think, well, I'd rather not be in that position, but my main concern is the people who haven't caused the problem, who live in the lower latitudes, and for those people, a 4 degree C rise, if you look at it in terms of their food, now there's a lot of uncertainty here, and this is not driven mostly, I gather this is driven mostly by the increase in temperature, rather now than by the changes in precipitation, by rainfall. At 2 degrees C, you've got a lot of rainfall movement, and to be blunt about it, the models are very poor at estimating where the rainfall will go, but they're quite good at estimating temperature issues. So as the temperature goes up and up, actually the crops don't start to grow simply because of the temperature being higher. So 4 degrees C, according to the Hadley Centre, 40% reduction in the staple crops, maize, rice, those sorts of crops. At the same time, the population heads towards 9 billion. So we're going to be struggling over here, and some of the poorer parts of the world will be really struggling for just the basics of food and so forth. So that's a world that I should say we have to avoid at all costs. And I think that's what comes out from, if you talk to a lot of scientists who work in this area, they would suggest that a 4 degrees C temperature rise is probably incompatible with a organised global community. We're probably going to fight, which we're very good at. And we blame everyone. I mean, we blame the Poles at the moment for a slight dip in our economy. We always find someone else. Whatever happens, it's never our fault. It's always someone else's fault. It would be certainly a Western trait, if not a human trait. And it's beyond adaptation. A lot of people are arguing that actually you won't be able to adapt to this. And some people will adapt by dying, if you call that adaptation. And I've heard that from quite a few academics, so we'll muddle through. We'll muddle through. I'll go and visit my uncle in the west coast of Scotland on the Isle of Arran, whilst people in Bangladesh die. That's not muddling through, in my view. It's devastating for ecosystems. Ecosystems do evolve, they can change, but they can't evolve at this sort of rate. So it's probably devastating for ecosystems. And of course, we're in the way of many ecosystems. Ecosystems have traditionally moved when temperature changes, but now you've got cities in the way, and roads in the way, and migrating populations forward. And it's highly unlikely to be stable. As you head towards these sorts of temperatures, all this analysis does not assume any of these things called tipping points, discontinuities, non-linearities, and so forth. So it's highly unlikely to be stable. So if you see 4 degrees C, it might well keep going up to 5 or 6. You'll start getting other feedbacks. And eventually the planet could actually feed back, and actually what we do is pretty irrelevant. And so I think it's fair to say that a 4 degrees C type future, moving in that direction, is simply something we can't contemplate. We have to avoid it at all costs. So that takes us back to 2 degrees C, or 3. I mean, we're on the probabilities of exceeding 2 anyway. 2 degrees C mitigation, it puts this in some sort of quantitative sense now. What's that require for those of us in wealthy parts of the world, for the OECD countries, UK and so forth? That's about a 10% per annum reduction year on year, and we should have started some time ago. 10% every single year. If you think that's about a 40% reduction in emissions by 2015. If you think about our own emissions, and my guess is that probably quite a few of you here, some of you here will be average, some will be above, and some will be below. A lot of the places I go, there's nowhere below. Everyone's way above the average. And you say to them, do you think you're going to manage a 40% reduction in your emissions by 2015? Do you think you're going to make a 70% reduction in your emissions by 2020? That's the sort of numbers we would have to see in the wealthy parts of the world, give the poor parts of the world a little bit of emission space for an outside chance of 2 degrees C. And basically by 2030, come back to the decarbonisation targets if you want to look at them. I'll be writing something about this afternoon on the way home actually. The decarbonisation targets have to be nearly 100% for 2030. That's not just electricity. That's every form of energy. If you want to give a bit of space to the poor parts of the world. And the reason people argue about different targets is because they're not giving the space to the poor parts of the world, and they're not saying that. Now that's impossible. That's what everyone tells me. That's impossible. Well, about living with 4 degrees C, that's also impossible. So the mitigation is impossible, and if we don't mitigate, the world we live with is also impossible. So in that sense, I'm making this sort of, it sounds flippant, it's not meant to be really, that the future is impossible. We can't stop getting there, we can't live there when we do get there. So what can we do about it? We have to think differently. The reason it's impossible is we have a particular mindset, and we've got to get out of that mindset and start to think differently about the challenges that we're facing. And if we keep using the old mindset, it might guide some of the things we do, but we keep using it to try and resolve these problems. And it simply isn't appropriate anymore, and I'm going to come back to that in the next few slides. This is all pretty despairing stuff, and I keep getting told that it's all doom and gloom. Well, I'm not. I'm just a messenger, so don't really shoot me. But I am going to try to make some comments that I've been using with Manchester City Council, with their Economic Scrutiny Committee a couple of weeks ago, and with other events with them. And I think there are some more positive directions that we can move that mean that 2 degrees C is not yet impossible. Still challenging, I think it's fair to say. So the 3 things I'm going to touch on here. One is on equity. I think the equity dimension might give us a message of hope. It's also a very challenging message that comes out of the equity issues. Technology, there's a lot that technology can do. As an engineer, I'm really keen on technology. And also I'm going to say something about growth, which actually will feed, I think, into your agenda, particularly today. Is it a useful proxy, or is it a destructive dogma, or an obstructive dogma? Destructive dogma, I think, probably better. So let's look at the equity one first. Who are the emitters? We know who they are. We see them when we shave or we've got our makeup on. And that may not be the case for everyone here, but most of the places I go, it is that same group. There are 7 billion people. Do we need to make policies for 7 billion people, or do we make policies for the people who are actually causing the problem? It would seem wise to me to actually tailor your policies to the people who emit. And how many people are emitting? This is one of the it's more than a misnomer. It's a deliberate ruse, I think, in a lot of climate science, and not climate science, but discussing about climate change. People say it's a population issue. I think it's a consumption issue. I'll come back to why that is. Wilfredo Pareto, a famous Italian economist, but I came across this as an engineer, the 80-20 rule. Broadly, 80% of something relates to 20% of those involved. This is just a ballpark guide, and it works for many aspects of life. It gives you a feel for the things you're looking at. And actually, it holds quite well for emissions. 80% of emissions comes about 20% of the population, there or thereabouts. It holds quite well for income, and it's not quite so well for wealth, but it's still not bad for wealth. Now, if you then say in that 20% of the population that are responsible for most of the emissions, who in that particular group is responsible? Can you do the same thing again? In that group, you see the same division again. And actually, from some of the work we've done and some of the work we're doing and other people are doing, it does seem to be that you can keep doing that. And if you do that, at least theoretically on its own, it would suggest you'd have a 50% reduction in emissions. Sorry, 50% of the emissions, rather, come from 1% of the population. Now that's great. That works in textbooks on a page. In reality, we're talking about 40 to 60% of emissions come from somewhere like 1 to 5% of the world's population. It probably isn't that different in quite a lot of the Anglo-Saxon countries. If you look at emissions in the UK, I bet they're spread like that. They won't be even. So that's, I think that says a lot about who we need to reduce their emissions. We need that particular group. But who are they? Climate scientists. I haven't met one that isn't like that yet. And they've even on planes to some jamboree around the world. So every climate scientist, every journalist, pontificator, skeptic, the Lawsons, the Lillys, the David Shukmans, the Harribins, they've always been reporting somewhere exotic in the world or flying back from another tour. Every academic that I've ever come across, because they're always after international conferences, they're really important. You've got to have this cultural exchange. Yeah, often I think if you have cultural exchange in Manchester, Cheetham Hill is an area just a few miles north of the university. Most academics have never been there. There's a cultural exchange, and you can get the cham out there. Anyone who gets in a plane once a year, you start to put yourself in that category. And I've made a bit of a guess here, maybe well into this. If you're heading towards 30k a year in your income, you're probably moving in that category. You're probably in that category or moving towards it. So in other words, what I'm saying here, from a global perspective, is many of us, not all of us, but many of us are actually in that 1 to 5%. So we know the people who've got to make the reductions, and it isn't some other people somewhere else. And the argument's often been, well, the Chinese are trying to live like us. Take the average, not the mean person, the mode person, the typical person in China. Increase their emissions at about 10% per annum, and the emissions aren't high enough to really matter too much till about 2025, 2030. By that time, we have to have low carbon energy supply in place, or it's too late anyway. So the thing that matters in the short to medium term is consumption by a particular group. It's not a population problem. Sustainability may well be a population problem. Climate change is a consumption problem. Mitigation is mostly about the few, not about the many. So I'll say something about that. So I'm suggesting that gives us some handle of hope, because we know who the emitters are. That unfortunately, they're the same people that make the policies. It's a bit tricky. It's the foxes that have to make policies to put better wire mesh around the chicken coop. So let's now look at technology and refocus here on demand. So I'm not looking at supply technologies. There's lots we can do there, but they're a long way away, and they're really important, and we need to get them in place. So I'm not saying we shouldn't do them. We need to do them, and we need to do them much faster than we're doing them now. But the demand side can deliver much quicker than that. This is an old slide I've used, and since using it, a few things have changed, but not a lot. If you want electricity or light, okay, these are quite efficient, but still a lot of lights around the world are incandescent light bulbs still. Thank you very much. Okay. Also refrigerators. If you have an A-rated refrigerator, it's likely to have more emissions, by about 40 to 60% more emissions than an A++ refrigerator. So you think there are huge things that we can do on the demand side to reduce our emissions. If you have a lighting refrigerator, you require electricity. If you require electricity, you require transmission and distribution network, pylons and the cables under the ground. You also need a power station to be running, and you need the Venezuelans or some other poor people in the world to dig the coal out, well, or it's American coal we're burning a lot of there. So they're using shale gas, and they're sending us their coal. Hence our emissions went up last year. So then you can also be burning coal or gas that's produced from elsewhere in the world. And you start to put the numbers on this. If you want 10 units of useful coldness or light, then your system is probably going to have quite a lot of inefficiencies in it, your appliance, which you can make much more efficient if you swap from an A-rated fridge to an A++ fridge. A-rated fridges are rubbish. They should not be sold. B and C are much worse. But your transmission and distribution network will lose somewhere between 6 to 8%. Most of it actually is in the low voltage stuff under the ground in your cities. The high voltage pylons are pretty efficient, about 2% loss. Power stations, constrained by the second law of thermodynamics, they're by and large somewhere between 35 and probably 55% efficient. 55% is pretty good. I mean, once you start running them, they probably don't run quite at that. And you can't get them much higher than that. The normal sorts of power stations. And then you've got to get the coal out of the ground, put it on a train, to a port, onto a ship, onto another train, onto the power station, and do that every single day for the 40 years of that life of that power station. So you've got to put that in. And so you start to say, well, actually, if you save something here, look at the saving you get here. You get all the discussions around power stations. Switch the lights off when you leave a room. Buy a smaller refrigerator, get an A++ one. You know, do something, do things that are different at this end, and you very rapidly change this at this end. And I haven't put a slide on here, but I have another one on cars, and it's worth bearing in mind that about 80 to 90% of all the vehicle kilometres travelled by cars are travelled by cars that are under 8 years old. So if we said that the standard had to be at the best that's available on the market now, not including hybrids, just normal internal combustion engine cars, we would see about a 50% reduction in emissions in something like about 10 years. If we just put a standard in for current cars that are available on the forecourt that use diesel as normal cars do, that's not even hybrids or electrical, it's not public transport, it's not cycling, it's not walking, it's normal cars that do normal things. If we said you had to have the best available, had to become what you all use, then you have about 50% reduction. So we don't need new technology there. So the demand opportunities dwarf the supply side, and we need to be putting them in place really quickly. Growth. These are the final few slides, hopefully give them the minutes there. I would argue it's a misguided proxy, and probably touching on some dodgy terrain here with some of you, perhaps. Stern, the Committee on Climate Change and others make the point that mitigation, reductions in emissions of over 4% per annum, are incompatible with economic growth. But at the same time, I think if you look at the economy at the moment, I'm not too interested in what the economists have to tell us. The economy is broadly stalled. Self-regulated markets no longer regulate themselves, if they ever have done. We've pumped 350 billion quantitative easing into banks. Where's it gone? Yeah, we have the money. We're not short of resources. It's been essentially squandered. We could have done something much more with that if we thought differently about these sets of issues. We are in an unprecedented times economically now. This is a great opportunity to actually think differently about the problems, not just the climate problems. We've got these other sort of economic issues, which a lot of our economists are saying they haven't got a clue about. I think most of them are saying. They're saying, or they're obviously demonstrating it, they haven't got a clue how to get out of this situation. So we've got this sort of combination of two sets of events that I think if you put them together and think more innovatively about it, we may be able to bring them together to give us all a lower carbon and a higher quality lifestyle. So growth is a proxy. No one wants growth. What you want is better health, better life expectancy, improved welfare. You want your employment to be good. You want your income to be reasonable. You want it to be a much more equitable society. You want the literacy rates to be high. You want there to be less crime. They're the things that you want. So why measure it in growth? You know, a tanker accident is growth. You know, these are the things we're looking for. We know what the things are out there. Growth itself is a proxy, and I would argue it's a very dangerous proxy. In itself, it's meaningless. So if you imagine the UK, rather than putting £350 billion into the bankers' hands, and admittedly a lot of it was only digital money anyway, but even if you put a good chunk of that into the UK's built environment, so to say we want to make a much more green infrastructure. Joseph Browntree Foundation estimates that somewhere about 290 billion was required to retrofit all the houses in the UK to make them low carbon and resilient to a changing climate. And that, they said, where we get 290 billion? Well, from the banks. Yeah, that's much less than we put into QE. So the money is there to do the sorts of things, the sorts of changes that we need. And if you think about retrofitting the housing stock, let's forget the environment, let's forget climate change. I mean, it's always relevant anyway. And this is what matters, isn't it, really? That's not what I don't mean that's all relevant, but I mean, these other things that really matter. If you improve the housing stock, you reduce fuel poverty. That's 20% of the houses in the UK. So somewhere about 5 million homes, if you improve the quality of those homes, they would come out of fuel poverty. They would reduce their energy bills, and hence their emissions. You increase their resilience to volatile energy prices. So these are all good things, regardless of the climate. You provide mass-skilled and semi-skilled employment. Because a lot of these jobs do not require highly skilled people. They can be trained quite quickly to do these sorts of things. And at the same time, you reduce emissions, which I think is quite good, and you make your whole world much more climate resilient. But these are almost add-ons. It just seems, why aren't we doing these sorts of things? Think of the transport network. If you do that, if you have a rapid transition to a low-carbon transport network, you reduce air pollution. That means you improve the bronchial conditions of the poor people that live on the roads. You reduce accidents. That would be quite good. And when you train someone up, they get killed in a car crash. 3,000 people killed roughly a year. I can't remember the exact numbers. It's between 2,500 and 3,000 people a year killed on the roads. Many other people injured. You reduce those accidents. That's good for the economy. You reduce congestion times. That means you improve productivity. And that encourages inward investment because your cities are now working much more efficiently. So all of this is good stuff. And at the same time, you reduce emissions. So we need to be thinking about how you ally these two sets of agendas together. And I think that they can come together, but I still think we have to move away from economic growth as our proxy. We have to look at the things we really want to measure. Ultimately, in the last two slides now, I think we must escape the shackles of the 20th century thinking that we have, 20th century mindset. If we're ever to resolve 21st century problems, at the moment we still think as if we're in the last century. That's not good enough. We are in the 21st century. We have to think quite differently. Just think about it, we're in the 21st century, and then the Mercedes-Benz diesel engine, the steam turbine, was designed about 1890, and we're still using those to generate our power. The jet engine, the British jet engine, was, as I said before, 1936. So in the 21st century, we're using devices and designs of energy systems that actually come from well over 100 years ago. And I would argue that this sort of shift that we need to make will actually demand a huge amount of leadership. It will demand a lot of courage from all of us, from our policymakers, which we should try and support them when they are courageous. It will demand courage from us, from the electorate, from organisations, from companies. And it will require innovative thinking, to think really differently, not to always knock people down for saying things that maybe not particularly popular or unusual things they might be saying. We need to be much more engaged collectively as teams, and we have to accept the fact that the world will be awash with difficult choices. And for quite a few of us, professors like me, we will have to take a big hit in terms of the sorts of things that we can do in our lifestyles. As Robert Unger noted some time ago, I think it's a wonderful quote, I use this repeatedly, I don't pay many royalties. At every level, the greatest obstacle to transforming the world is that we lack the clarity and imagination to conceive that it could be different. And the future is impossible, as I tried to describe before, unless we start to think differently. When it's forced upon us now, we have to think differently, we have to conceive alternative futures. And I think if we do think about those things in the short to medium term, or almost immediately start to think about them, then there is some real hope for us, at least the 2 to 3 degrees C temperature level, to actually probably build a relatively low carbon society that is climate resilient as well. So I think that is my final slide. I've got a website with some works on there, so feel free to go there and have a look at it. I've also got one of those modern things. I set up recently a Twitter account where I post links to things that I've written and other interesting bits and pieces. That's the end. Thank you very much.
Thank you very much, Kevin. I think on that last slide there, I think you do have a lot of sympathetic ears in the audience on the question of growth, I think, but maybe that's something that people can debate and discuss. We're very stupidly behind time, but it seems wrong not to give the opportunity to have some questions at this stage. So, wow. Okay. Let's take 2 or 3. Are people happy that we're behind and they don't mind having the agenda pushed back? Yeah. That's an agreement. Right, okay. Let's take 2 or 3. There was a mic. Where's the gentleman with the mic? Could I have somebody who's... could somebody, one of the stewards, any stewards in the room, could you just grab the mic and take it to the people that I'm going to point to? Okay, so the mic is here, a steward, no steward, right, okay,
I'll hand it back.
thank you, thanks John. Right, okay, so let's take the gentleman at the front here. Could you just pass the mic to the gentleman at the front here, and then I'll take you in the green here, and then there was a woman had a hand up somewhere, please, could you just, no, okay, all right, okay, and then next here, all right, go for it.
My name is Art Heesterman. Would you be so good as to apologize for calling me an astrologist? I do consider myself an economist, and the book we have on the table there contains some basic criticism of some of the usual assumptions underlying regular economic analysis.
Yep. I was particularly talking, I'll hold the body back to leave. Let's respond. Oh, do we have two or three first?
Let's do two or three
yeah.
first, and thank you very much for being short, brief, not for being short. You're not short. That's not how we're going to reduce the consumption, I don't think. That's not how it's going to be done. Thank you for being brief. Can we keep it? Yeah, so here.
Yeah, quick one.
And then you.
You described all the necessity of certain category of the population reducing emissions. What about the rebound effects, though, of that? Can you just say something about that?
And one more.
I just wanted to ask, you focus very much on individuals, and I wanted to ask what your opinion may be on more collective responses. I mean, it strikes me that the protests, for instance, in Istanbul in Taksim Square began with a response around parks and green, and have become much more wider questions, and I wondered whether how you saw that fitting in.
Yeah. Right, firstly, apologies. I'm talking about a particular group of economists. They're the market marginal economic economists. There are lots of other colleagues I have who are ecological economists, or there's a whole array of economists out there, and they take quite a different approach. But even the market economists have a small niche job to play somewhere. Basically, the reason I'm concerned about economists being involved is they're talking about changes that are large, and they're using theories that are talking about changes that are small. So it's like using Newton mechanics to understand quantum mechanics. You wouldn't do that in physics. So why are we doing it in economics? But overall, I apologise, and I apologise to all economists. But the marginal ones have a very small role to play, but they completely dominate economic thinking in government and actually in many universities as well. On the second point on rebound, that is really important. In fact, you can talk to the economists about that. There's been a lot of good work done by Steve Saul at University of Sussex on rebound. It's a real big issue. The Sussex work has broadly shown that about 30% of the energy saving comes back in rebound. Other people argue it's as high as 100%. So you can't have, even if you have energy efficiency, there's no point having energy efficiency without another policy that compensates for the rebound. So if people can save energy, save money on being more efficient, they'll spend it on a jet ski or a holiday or something. So you have to have some other policy that compensates for that, and there are lots of things you can do. I don't think the price of energy should go down for those of us like me who can afford it, and I think we should be more efficient, and the price of energy should go up. And then we just pay the same price for our services. So you have to have a policy that compensates for the rebound. It's a really important issue. A lot has been written on about it, and I recommend Steve Saul at University of Sussex. And the final one, collective. Yeah, I couldn't agree with you more, but I think we have to be fair on climate change. We haven't got a clue how to solve this problem. Now, whether it's going to come from one individual somewhere triggering something, or whether it's going to come from some great benevolent dictator passing things down, I don't know. I think we all need to try, as individuals and our families and our friends and our companies, and as ad hoc institutions that are emerging out, some of the sort of Arab Spring things, or maybe emerging in Turkey, or it could also be that governments can engage in that as well. We need to seed everything we possibly can, and then we'll look for where the flowers start to sort of come forth, and then try to fertilise them and look after them when they do come forward. But I'm not saying that it's not all about the individual. It's about us all trying at every single level, as individuals, right up to the biggest collectives, even the UN, everything at that level.
Okay, thanks. We'll take you here, followed by yourself here, and then right at the back. Sorry, yes, right at the back. And then we'll see where we're up to, Gus.
So I was going to ask about some recent remarks by another climatologist, Miles Allen, who's been writing in the Daily Mail and then recently in the Guardian about how carbon capture and storage is going to help us meet our carbon budgets.
Okay, yes.
This lady here.
There's one thing which you didn't mention about it, that's eating less meat.
Thank you for being...
Which we can all do.
Yeah. So that was, the one thing that wasn't mentioned was eating less meat. And at the back,
Hi, I thought that was an absolutely incredible presentation, and it's going to merit considerable analysis and stuff. But I'd like to take you to task on 2 points you made. Early on in an early sentence, you said that 2 degree Celsius temperature rise may bring benefits to the UK and Russia. Now, that's going to be wiped out by weather volatility that we're already experiencing. So, I mean, you can't really predict any potential benefits at all. Secondly, you made a very casual aside about biofuels as a renewable energy and a potential help. And I hope you stay around later, because I'm going to make a very brief presentation about biofuels that I think will clarify that mistake.
Right.
Do you mind if I take a couple more?
No.
So,
This is one with the arm, isn't it?
This one there, yep. Yes, yourself, yes.
Actually, the lady sort of beat me to it. I was going to mention the meat issue, but I was doing a thesis actually looking at biofuel impacts, and I found that livestock, and apparently there's 60 billion livestock now in the world, including all sorts of livestock, and they're obviously breathing out a lot of CO2, as well as the methane. But if you count the deforestation for growing the soya to feed them and for grazing, I've heard that far more of an impact than transport in total. And that's an FAO report in 2006 said 18% of all anthropogenic emissions.
Okay.
And I've just heard that the quickest impact we could have in reducing things is by letting trees grow instead of knocking down loads of forest for livestock feeding.
Right, I'm going to ask Kevin to respond to those. I'm going to try for a few more, but can we keep them questions, not contributions?
Right, Miles Allen. I have a lot of time for Miles. He's an excellent scientist. He's not an engineer. And I think I've said these sort of things to him directly. A lot of scientists think that engineering is something you take out of a science textbook and produce in reality. As an engineer, it's actually built rigs and worked on ships. That's not how it works. Carbon capture and storage, there are no big plants around the world. The largest one, I think, is 0.5 gigawatt. And the big power stations are at least 1 gigawatt. So even if you can put it in place, you can't absorb all the CO2. So at the moment, we have no demonstrable big plants that have run for any period of time. And even if you can put them in place, the best estimate for gas carbon capture and storage is 80 grams of carbon dioxide per kilowatt hour generated. And if you do the maths on that, because a lot of scientists assume it captures all of it, it doesn't. That's the best you're going to get, is about 80 grams. So you still get quite a lot of emissions from it, compared to, say, nuclear renewables, which are probably in the, if they're well done, they're probably in the 15 grams or lower carbon. So CCS, even if it works, will not be enough for the West. But we do need to pursue it. But it's completely wrong if you think so that will solve the problem. We won't be able to put it in place fast enough. And a lot of people object to the pipelines going to their communities as well. On the meat issue, I mean, I just agree. I'm a vegetarian since 1987. I'm not against people eating meat. My uncle was a crofter on the west coast of Scotland and had a sheep farm. I don't mind people eating meat as long as it's grown. You eat it very occasionally. It's grown well. It's humanely killed, and it's done as a celebration. If we really, I mean, I'm not going to do that, but I don't really object to other people doing that. Having a little bit of meat, it's the level. Like most things in life, it's the scale. Meat is a huge issue. I wouldn't say it's necessarily more than transport. It depends how you do those sums. But meat is a big issue. The deforestation is a big issue. The food that goes into it is a big issue. I think it's roughly right, and some other people will know better than me, it's somewhere between 7 and 13 times the amount of land that's required to generate the equivalent number of calories from meat compared to generating those calories from some other form of vegetable or arable crop. So yes, I think...
interject here. This conference is about jobs.
Yeah.
My partner, colleague here just mentioned that. You get more jobs from traditional farming.
Okay, right.
Yeah.
Can I stop you there?
On jobs?
Yeah.
And the fact, if we went
to
a vegetarian diet,
sorry, guys,
created
I'm going to
more
stop you.
jobs.
I'll tell you why I'm going to stop you. Partly because there's a session, a workshop coming up on food. A good place to put those points and those arguments and those debates.
Yeah. I mean, I'm not disagreeing with anything. I mean, I pretty much agree with everything people have said about this. The next one was about the 2 degrees C, the benefits. All I'm saying is that there are lots of people, the big science group in Norway, which I think is called Rosmat Hydro, they're saying that 2 degrees C, they would expect to see some significant benefits in sort of agricultural production. Now, I accept it's a short-term thing, and it depends what else happens. I mean, Russia's a huge area. A massive part of it is an area which is basically is frozen. So that would help them. But they're already having problems. The infrastructure they've built into the frozen tundra there is now starting to struggle because the tundra is starting to melt. So they'll have to actually fundamentally change the infrastructures in those areas. Having said that, they do make the case quite strongly, which we may or may not agree with. I'm not saying I do agree with it, but I have done quite a lot of work looking at that in Russia, that they think 2 degrees C would have some benefits. It ignores the fact that lots of people might be migrating there from poorer parts of the world. So the other on biofuels, a lot of work is done by a colleague of mine, Patricia Thornley, who runs a big network on biofuels, and her and I often discuss these sets of issues. I'm broadly of the view that biofuels may well be part of our mix, or biomass might be, but we shouldn't be importing any. So any biofuels we should use should be used in the UK, things like forestry residues, crop residues and so forth. I don't particularly like the idea of planting the planet up to produce biomass and biofuels, but other people disagree with that. But the other day when we started burning American trees in British power stations to produce power, seems absolutely ludicrous to me. So I'm probably with you, I think, what going on biofuels. And trees, yes, they do sequester, but there's no guarantee with them. So I think we should plant as many trees for other good tree reasons, not for CO2 reasons. Because although they may sequester some carbon, they can also, if the climate changes or we get changes in pests, they might actually end up rotting and producing methane, which is actually worse than the CO2. So we should be planting trees, but if the temperature is at 4 degrees C, what's going to happen to those trees? So I don't think you're locking the CO2 away. I think we have to be very careful about that, because people are using it as an offset. Yeah, they'll fly somewhere and plant some trees. They're not the same thing.
Okay, we've got one more here. I'm going to take 3 more. Yourself and the gentleman there as well. Okay, yourself, yes.
Alan McFadden, President of Mersey TUC in United. I was a bit surprised you didn't mention capitalism as an obstacle. I'm really surprised. Secondly, I mean, if we're going to think in the 21st century and collectively, as Martin said, surely we should be reconsidering an integrated transport system, the renationalisation of rails, and stop producing cars.
Some support there.
Thank you. Kevin, I missed most of your presentation, but I did catch the tail end. I'm not of the view that economics is actually a science, even though I've got a master's in it. But I suspect you're of the same view. But I was interested in your comments about the printing of money, the quantitative easing. As you rightly said, there have been something like 300 billion printed, ostensibly to maintain demand in the economy. I'm just wondering, I feel we've come to a point where we've got to ask ourselves whether growth models are the best way going forward, or do we deal with what we've got on our plate? Because I think this is what some people are suggesting around here, changing our eating habits and the way we move around. I think that's where we need a direction from people like yourself.
Well, let's take these 2, and then we will have to finish there, I'm afraid, and then just...
Kevin, could you comment, please, on the potential of solar radiation as a route to cool the planet?
Yeah.
And sorry, Jonathan, the gentleman there in the sort of grey shirt, yes, and glasses there, yeah. And then we'll call that day for this section.
Considering the urgency of the problem, why do so few climate scientists communicate the urgency to the wider population?
Right. Right, if I forget any of these, just remind me. Capitalism, integrated transport, and stop producing cars. I think I stray quite a long way from my academic framing of my research. I'm not sure I should go quite that far. You may have those views, and I may have them, but I'll have to stay relatively quiet on them one way or another. Certainly, I think we are saying we've got to question some of the models that we have. Integrated transport, I mean, we've been talking about it for years, and no one, I think, would disagree. That's a not a sensible thing to have. Stop producing cars. Maybe gradually phasing them out, but there are lots of jobs for them at the moment, but they are very polluting. And perhaps if we had cars that were things that were in car clubs and they were very low carbon, then maybe that wouldn't be such a bad thing. I don't know. I'm uncertain as to the rural environment whether public transport is the best way forward. I think it depends on where you live in the rural environment. Certainly where my uncle lives in the west coast of Scotland, it would be wise to have a bus, because there'd be no one at the bus stop. So the other one, the economy, I'm not sure I fully understood the
Quantitative easing, is that the right way to go?
No, I think it's a complete mistake. But I think the whole framing of the economy has been from an economic perspective. There's a whole set of other stuff around this. I take this view that economics comes from the Greek word oikonomia, which was stewardship of the household. And to me, that is the way we should be thinking about economics today. The modern form of economics comes from the Greek word privatistics, which is the making of money. And actually, I think if we went back to stewardship of the household, that form of economics is the sort of economics which actually is embedded in a lot of ecological economics. That's the sort of economics that I think would really help us now. So I'm talking to Manchester Council, we're doing a lot of work on steady state economics. Now, I quite like some of the stuff that came out of Herman Daly and others. Other people may say it's not quite appropriate, but I think we have to think very differently about the economic model. And the QE version, the version we've got now, is, I mean, it's defunct. It was evidently defunct before we used it. Solar radiation management. And for those of you who aren't aware what that is, that's basically reflecting the sunlight back out into space to stop it warming the planet. I use the analogy, it's a bit like if you've got gangrene and you've got a plaster on it. So it's unlikely to be successful in the medium term because the gangrene will spread, you won't see it for a little while. So the problem with solar radiation management is that firstly, who will use it? The people that can afford it. Where will they protect? I'm sure it won't be the poor and the people who haven't caused the problem. Secondly, whilst you've got solar radiation management, it allows you to keep putting CO2 in the atmosphere, because you'll say, oh, hey, the temperature's not going up. If you keep putting the carbon dioxide in the atmosphere, the oceans become more and more acidic. They're about half a pH point more acidic already. So you get more acidification in the oceans, and we don't know how that will play out with ecosystems. We shouldn't muck around with ecosystems we don't even understand. So I'm very sceptical of solar radiation management. I think some of the other geoengineering options that suck CO2 out may have a small role to play, but I think they're being over-egged. But solar radiation management may be appropriate if we could use it collectively to protect particular vulnerable areas. And if it did work, and we could use it to protect the Amazon or Greenland or something, then it may be fine. But my feeling is that we looked to protect some nice gardens in Boston, rather than necessarily where it should be. So I think there are real equity implications for solar management, assuming it works. And the CO2 implications for oceans, I think, is just unacceptable. And if you didn't keep it up, then you'd have a step change, almost step change as well. If for some reason there was a war and you lost some way to maintain the solar radiation management, the main way of doing it, people are talking about, if you're not aware, is to pump sulfates. You fire rockets into the stratosphere, which we don't understand the chemistry of. You fire rockets into the stratosphere and you pump sulfates into the stratosphere. And those sulfates reflect sunlight back out into space. Then gradually the sulfates will probably migrate out towards the poles. That's the main way that's been talked about. There are other ways you can do it by increasing the number of clouds that are produced and things like that. But they are very uncertain. It always reminds me of cane toads in Australia. What was the last one here? Solar radiation management. Scientists communicate. That's right, yeah. Someone's got to pay us. There's a whole load of stuff behind this, and lots of scientists are arguing about it. I've been battling with quite a few on websites and some papers as well. Scientists have to be paid. They're worried about their position, their mortgages, the sorts of things that we like doing. Academics like flying around the world, so if you say it's really, really urgent, it will suggest you should be doing these sorts of things. The research councils aren't particularly keen on us coming in there questioning things like economic growth, for instance. So the whole structure, the way science is funded and operated, is one that does not really want us to be raising the sorts of questions that we're raising today. It wants us to remain a very sort of neutral scientific perspective. I would argue at the moment that the strongest advocates from the climate community are those that are staying quiet. So I'm deafened by the roar of scientists who are not saying this is an urgent issue. So, I mean, I think advocacy is effectively that idea, when you're agreeing with something by staying quiet. It's the silence of consent. But there are lots of good reasons why scientists aren't getting involved. I have lots of battles with them. A lot of them are personal, to do with their colleagues, but also to do with their families and how they see their own lifestyles. But an important point that needs to be addressed.